You are about to spend 1/3 of your entire life unconscious, and science is only beginning to understand why. Most people think sleep is simply rest, the body powering down for a few hours before the next day. But what actually happens inside your body when you sleep is one of the most extraordinary processes in all of biology. Tonight, while you sleep, your brain will replay every important memory from your day and decide what to keep forever. Your body will release more growth hormone in one night than it does in an entire waking day. And your brain will literally clean itself, washing away the toxic waste products that accumulate during waking hours. Today, we go inside every stage of sleep, in full 3D, to show you exactly what your body is doing while your eyes are closed. Sleep does not begin the moment you close your eyes. It begins hours earlier, with a biological timer that has been running since the moment you woke up. Your circadian rhythm, a 24-hour biological clock built into virtually every cell of your body, orchestrates the timing of sleep with extraordinary precision. As daylight fades and darkness arrives, your eyes send a direct signal to a tiny region of the brain called the suprachiasmatic nucleus. This nucleus signals the pineal gland, and the pineal gland begins releasing melatonin, the hormone of darkness. Simultaneously, adenosine, a sleep pressure molecule that has been building in your brain all day, reaches its peak. Adenosine is the reason you feel more tired with every passing hour of wakefulness, and it is the exact molecule that caffeine blocks. As melatonin rises and adenosine peaks, your body temperature begins to drop. This cooling is one of the most powerful triggers for sleep onset. Your heart rate slows, your muscles relax, and the brain begins its transition from wakefulness into the extraordinary landscape of sleep. What follows is not a single state of unconsciousness, but a highly structured journey through distinct stages, cycling through the night. Sleep begins with stage 1 NREM, the lightest stage, lasting only a few minutes, where you drift on the edge of consciousness. In stage 1, your eyes move slowly beneath closed lids, your muscles occasionally twitch, and vivid images may flash briefly through your mind. Stage 2, NREM follows. And here, two remarkable electrical events appear in the brain: sleep spindles and K-complexes. Sleep spindles are generated in the thalamus, and they serve as gatekeepers, actively blocking external sensory information from reaching the sleeping brain. K-complexes appear in response to sounds or disturbances. They are the brain's way of acknowledging a stimulus while simultaneously suppressing a full awakening. Stage 2 also marks when your body temperature reaches its lowest point of the night, dropping by nearly 1 full degree Celsius. Then comes stage 3, deep sleep, also called slow-wave sleep. And this is where the most extraordinary physical restoration occurs. During deep sleep, the pituitary gland releases the largest pulse of growth hormone of the entire day, flooding the body with repair signals. Muscle fibers torn during exercise are rebuilt. Bone density is restored. The body's physical infrastructure is repaired and strengthened. The immune system is supercharged during deep sleep, releasing cytokines and producing immune cells at an accelerated rate. This is why you feel so much worse when you are sick and cannot sleep, and why sleep is the most powerful medicine for recovery. Deep sleep is also when the glymphatic system, the brain's waste clearance system, reaches peak activity. The same amyloid beta protein that accumulates in Alzheimer's disease is cleared during deep sleep, which is why chronic sleep deprivation significantly raises Alzheimer's risk. After the body has been physically repaired in deep sleep, something equally remarkable begins: REM sleep. REM stands for rapid eye movement, and during this stage, your eyes move rapidly beneath your closed lids, tracking the vivid dream world your brain is creating. Your brain during REM is, in many regions, more active than when you are fully awake. But your voluntary muscles are completely paralyzed, a protection mechanism that prevents you from physically acting out your dreams. The dreams you experience during REM are generated by an extraordinary collaboration between multiple brain regions. During REM sleep, your brain is performing emotional surgery, replaying emotional memories, but stripping away the distressing emotional charge. This is why you often wake from sleep with a clearer perspective on problems that felt overwhelming the night before. REM sleep is also the stage of creative insight, when the brain makes unexpected connections between distantly related memories. The hippocampus, your memory storage center, replays the day's experiences during REM, consolidating important memories into long-term storage. Memories that were encoded during waking become permanently woven into your neural architecture, while unimportant memories are pruned away. Throughout the night, your body cycles through these stages approximately every 90 minutes, completing 4 to 6 full cycles. The first half of the night is dominated by deep NREM sleep. This is when the majority of physical restoration occurs. The second half of the night is dominated by REM sleep. This is when memory consolidation and emotional processing take center stage. This is why cutting sleep short by even 1 or 2 hours disproportionately eliminates REM sleep, robbing you of memory consolidation and emotional regulation. Not everyone's biological clock runs on the same schedule. Chronotypes, early birds and night owls, are genetically determined. Forcing a night owl to wake at 6 a.m. is the biological equivalent of forcing an early bird to wake at 3 a.m. The circadian misalignment causes real physiological stress. Now, what happens when you do not get enough sleep? The consequences are far more severe than most people realize. After just 17 hours without sleep, cognitive performance declines to the equivalent of legal intoxication. Chronic sleep restriction, getting just 6 hours per night for 2 weeks, produces the same cognitive impairment as 48 hours of total sleep deprivation. Sleep deprivation amplifies emotional reactivity by up to 60% because the amygdala disconnects from the prefrontal cortex's calming influence. And perhaps most alarmingly, chronic short sleep is associated with a significantly increased risk of Alzheimer's, cardiovascular disease, diabetes, and cancer. Now, everything science has discovered about how sleep works points to specific evidence-based strategies to dramatically improve your sleep quality. First temperature. Your bedroom should be between 65 and 68 degrees Fahrenheit, around 18 to 20 degrees Celsius. A cool sleep environment helps your body reach its temperature nadir faster, dramatically speeding sleep onset and deepening slow-wave sleep. Light exposure is the most powerful regulator of your circadian clock. Morning sunlight viewed within 1 hour of waking sets your clock with extraordinary precision. Conversely, bright artificial light in the evening delays melatonin release by 2 to 3 hours, pushing your sleep time later and reducing sleep quality. Caffeine has a half-life of 5 to 7 hours in your body, meaning a coffee at 2 p.m. still has half its concentration in your bloodstream at 9 p.m. Exercise is one of the most powerful sleep enhancers, but timing matters. Morning or afternoon exercise dramatically improves deep sleep. A consistent wake time, even on weekends, is the single most effective behavioral strategy for improving sleep quality. The 20-minute rule. If you cannot fall asleep within 20 minutes, leave the bed and do something calming until sleepy. And perhaps most powerfully, understanding that sleep is not lost time, it is investment time. Every hour you invest in sleep returns compound interest in the form of sharper thinking, stronger immunity, better physical performance, and a longer, healthier life. Tonight, when you close your eyes, know that your body is about to perform one of the most extraordinary acts in all of biology.